Recording. Okay, so thank you very much, Professor. Hi, everybody. It's really nice to see you, all of you who managed to join us today. And I'm very proud and happy and inspired to present Professor Kim Albrecht with very many interesting projects on the intersection of research and art, because your research is really artistic. So I'll just give you the floor, and many thanks for being with us today.
Yeah, Irina, thank you so much. So I'm gonna start. I hope this will work. Start share slides.
Yep, it is working.
Okay, you should be able to see the
Yes.
slides in full screen. I hope this works.
Yes.
Fantastic. Okay, thank you everyone for being here. My name is Kim Albrecht. I'm a professor at the Film University in Babelsberg, in Potsdam, close to Berlin. I'm living in Berlin. I'm looking outside. It's already dark here. At the same time, I also have a position at Harvard University and at the Free University in Berlin through a lab that I'm leading, which is called the Meta Lab. And what we're doing at Meta Lab is like working on the intersection and the boundary between culture and technology in the broadest sense. So almost all of us have a background or some kind of connection between technological thinking. So thinking about data, thinking about algorithms, but at the same time from a very humanistic perspective. And like for the past, I would say like 12, 13 years, my thinking is interested in data and digital culture and how it's influencing how we perceive the world through it, how it's changing our perception and what this is doing. I have a background in design and graphic design and interface design. And then I moved into another position at a lab in Boston with Professor Laszlo Barabasi. He's very famous in like network science, and I worked in that lab for 3 years, mainly with physicists, before then moving into doing a PhD in philosophy and media theory. So it's like this very broad and wide thinking that connects my doing and making. And I will share mainly one project. But just in the beginning, to give you a little introduction of what the thing I'm talking about looks like, here is basically a supercut of projects I've done over the past 12 years. So it's always like I'm taking data and basically transforming data into a visual form. And that works within scientific inquiries. I'm working a lot with scientists, but I'm also working with museums. I'm making theater plays. So it's like all kinds of mixtures that are coming along. And obviously, one big part of our lab over the past like 8 years, I would say, is this notion of machine learning. And most recently, like one big topic became what we now call generative AI. And I'm not sure how many of you are familiar with this graphic. It is called the hype cycle from Gartner, and they put this out for all kinds of technological advancements. And what this is basically showing to you is over time, they have this notion or this idea that the technology gets into this hype and gets very much hyped, and but it's unclear what this expectation or what this technology will do to society. And then at some point it's falling off into disillusionment, and then the actual reason or the actual thing that technology is good in will be found. And at the moment, or last year, they put generative AI at the top of this hype cycle. So we're basically all waiting for the moment it's falling down, but it hasn't so far. But this is for me a very interesting way to think about this. And just like for those of you who might not be super familiar with all this terminology, I define generative AI as an artificial intelligence capable of generating new media. So some kind of algorithm that is capable of taking a training data set and from the training data set, create new data sets with similar characteristics. And this is very well known within this idea of the transformation from text to new text. That is what ChatGPT is basically doing. But we have the same thing for speech, for image, for video. And we could also change this. So you could turn an image into text. You could turn a video into speech. So this is what basically the promise is from generative artificial intelligence. It is a form that creates a mediation between different sections. And when it comes to my research at the moment, I'm looking at this at generative AI, which is called large language models, which is basically the translation from text to new texts. And these are at the moment very interesting to me because they are so hyped and there's so much that people basically put into and project into these models. So there was this paper coming out in 2013 or in 2023, excuse me, that says that actually GPT-3 is better at writing short texts such as tweets than humans are. So humans prefer those texts to those that humans write. And similarly, the European Union basically produced this document where they predict that artificial intelligence or generative AI will soon generate about 90% of the content on the internet. So there's this like big projections of what this technology will do and how it will act in the world. And I just went on and I'm making this collection of newspaper articles that talk about generative AI in one way or another. And there are two major things that I've seen. And the first one is this notion of AI and learning. So ChatGPT, the first year in college ends in ruin, how to spot an AI cheater. So it's all about like, how will education basically change with this new technology and how to make up with that, how to cope with that. And what I find fascinating is that there's such a strong narrative that seems to be always the same. And it's not only how we learn, but also another narrative comes from how we work in the future. What will work look like? And there are all these articles that I found that basically talk about how jobs will be demolished by this technology. And that is, I think, a second very strong narrative that I always see. So it says like how many millions or billions of jobs will be gone because of this technology. And then there's a third perspective that I'm interested in, and that is the more scientific perspective. And what we see there is oftentimes that the narratives are structured around the sizes of these models. So we see a lot of graphs that look like this, where different models are basically compared in their sizes, or graphs that look like this, where you have this like exponential scaling, and then you see the different models and how much bigger they get over time. And like while I think this is all good and this is all okay that people are doing this and this is a perspective that you can have, I'm interested in looking at this from a different perspective. So rather than projecting or taking a current technology and like doing this projection into the future and thinking, what will this be soon? I'm trying to have a different view on this, and the reason why I'm doing that is very well showcased by this image. So what you see here is one page from a magazine called The Popular Mechanics, and they basically published in the 1950s. They published one issue where they made predictions about the world in the year 2000. And so they basically made this like large look into the future where they said, how will the world look like in 50 years? And we are right now in this very comfortable situation that we know how the world looked like in 2000 because it already happened. So, and if you can't read this, it says, because everything in her home is waterproof, the housewife of 2000 can do her daily cleaning with a hose. And fascinating to me is that nobody I know is using a hose, and nobody has a sofa that is made out of plastic. If some of you do have a plastic sofa, please raise your hand. I would love to talk to you, but it still seems to be very unlikely. And something so and we have to put ourselves into the position of the origins of this magazine. So in the 1950s, it was a point when basically plastic was the new technology. Plastic was the kind of AI of that time. So there was this idea that plastic will take over everything and everything will become plastic because that is the newest and latest technology that we have. Um, and this didn't happen, but what this picture is also missing is the role of the woman in society. This housewife is not a prototype that exists any longer, and I'm very happy about that. So, and this is, I think, something that happens a lot in this kind of circumstances. We're underestimating cultural shifts and cultural change within society, but at the same time, we're overestimating technology and overestimating how technology will progress very linear fashion, that everything will become plastic in 50 years. So, and I'm interested in using art and design and to look into technology and to find new ways to think about how we can imagine culture being shaped by these things and how that might change also how we perceive them. So, and this is not that I came up with this, but it's a very common thread in media arts or in media theory. So in understanding media, Marshall McLuhan noted the ability of art to anticipate future social and technological development. Art is an early alarm system, pointing us to new developments in times ahead and allowing us to prepare to cope with them. Art as a radar environment takes on the function of indispensable perceptual training. And even before that, the artist Paul Klee often talked about art as making the invisible visible. And I think nowadays this is more important than ever because computer technology most algorithms work invisibly in the background and they remain very much inaccessible to the systems that we use every day. And I think that is where design, art, and creativity can help us to point at some of these hidden sides. So rather than looking at the current technology and extrapolating it into the future to make bold predictions what this will be, I like to look at where do things come from and then create some kind of intervention and a reflection upon this. And that said, I will introduce one project where you can basically see this approach. And the project is called Artificial Worldviews. So when ChatGPT came out, like I had this elaborate discussions with the system, and I was very surprised how well this technology worked and what it was capable of doing. And as somebody who works a lot with data, I very soon realized that ChatGPT was capable also of generating data, not like big data sets, but the small tabular formats of data. This made me very curious, and we had these discussions where I asked it to generate data sets that were unimaginable or that nobody could produce. And I came up with this question and asked ChatGPT to create me a data set of all the categories of knowledge that it had. And I told it that it should be a table with 30 rows and 10 columns. Interestingly enough, I didn't build that. But what it made was this like long lists of topics and subtopics. It said like, hey, we have the knowledge domain of animals and birds and fish and pets are in there and wildlife. And it became this extremely long list of over 500 subtopics. And this list reminded me of short stories from someone like Borges or Kafka. It was this like strange categorical creatures of inclusion and exclusion. And I was wondering, like, where does it come from, and why are these terms in there and other things not? Why is travel connected to solo travel or road trips? What is doing that the system decides for something and not for something else? And so I tried to further investigate this, and I went from this categories and subcategories into going into the APIs, so into the programming version of ChatGPT, and I started making over 1,800 calls. And for each category and subcategory, I asked it for the most important humans on the one side, and on the other side for the most important objects, things, ideas, places. And it came up with this list of items that is also online. You can look at the list. It is basically a Google sheet that you can access through the website. And this is basically how it looks like. So it's telling, hey, psychologists that are theorists, like Sigmund Freud and Carl Jung, and then it gives a description of these people. I ask it for related things. It gave me an importance, and then if it's a human or not. And this basically created each dot that you see is basically one response from the system. And then you see the subcategories and the categories that these things are based in. And to give you one view onto the data sets, so the smallest category is the category of nature, funnily enough. And then I had the objects and the humans, and then the subfields of nature like botany, ecology, fauna, flora, wildlife, zoology, and then all the items that came back within that. Algae is in there, there are reefs in there, there are birds, etc. And then because I also asked for related items, I got back this long list of things that are connected to those things. So, and for each category, I have this like hierarchical trees of relational data sets of this like hierarchical network structure. So, and for an individual item, this is what it looks like. So you have the category of literature, and then the subcategory of mystery and prose. And then within mystery, there's Sherlock Holmes, and prose, there's Baker Street, and they're connected to one another. And then there are more related items that are also connected to one another. And from this basic network structure, I was able to use an algorithm that is called a force-directed layout, and I let it run. And what this algorithm is doing is that basically every point, every request repels each other, and they try to be as far away from one another. But when they're connected, when there's a relationship between them, they pull together. So you're getting this algorithm that basically clusters this whole data set into this two-dimensional map. It's positioning the objects in relation to one another. And then the map that I made had like 4 layers. So first, this is a layer of the categories. So you had all these terms and how they relate to one another. And so you can see when things are closer to one another, they have more connections. And when they're further apart, they have less connections. So you see that geography, nature, and animals and environment are very close to one another. And you see that medicine and music are very far from one another. But entertainment, fashion, and music, and art, film, they all cluster at the top, while business, education, psychology somehow cluster at the bottom. And then I had also the subcategories, because there's so many of them. The text in this graph is very small. Then I had items and the related items. And this resulted in a map that looked like this. And it's basically this online map that you can go and explore on your own. It's this like visualization. You can zoom in, you can click on the things, and you can see how the different things are related to one another. And this is what I call, or what the project became, of artificial worldviews. And to me, it's a mapping of this algorithmic conversations with ChatGPT. And why I find this interesting is because machine learning is often referred to as this black box, but it's not really a black box because we can access it very well by talking to it. It's similar how we engage with humans. We don't have to look at your brain structures to understand your worldviews, but we can talk to one another, and then we get some kind of idea why somebody is saying something or how they position themselves in the world. And when it comes to this technological systems, the individual queries can only lead us to anecdotes, but this like structural large numbers of inquiries can give us some kind of idea what this, and can create this like kind of mappings. And I was very fortunate because after I published this research, I basically got an email from Nature, from the journal, and they asked me if I wanted to put this map on the December issue, the last issue of 2023. And I agreed and was very happy and honored that they decided to take this as a cover. And I wanted to go a bit into the findings of some of the things that I've seen and that I find pretty fascinating within this. And one thing that interests me was this notion of inclusion and exclusion. Why is something in the list and something else is not? So what you see here is a list of all the actors. So actor is like one category, and why is someone in that list and other people are not? Who's deciding on this? And to me, it feels like a representation of power, a representation between humans, data, and algorithms that create this kind of map. And the same thing is here. So here you see the full list of all the directors, all the movie directors that are named by the system, by ChatGPT. And you can do this for any category and basically look into those categories and see who's listed. And then ask yourself, is this really how we want to be represented and who we think should be in that list? Um, and I looked into this. So what you see here is on the one side all the photographers, all the kinds of photographers, 12 photographers named by ChatGPT within the process. And then I basically Googled lists of famous photographers on Google, and looked at the first pages that are basically doing this rankings, and looked at how they overlap and where they don't overlap. And it's kind of interesting that like somebody like Ansel Adams, everybody agrees like he's represented in all of those lists. But then GPT also mentioned things like Sebastião Saldago or Steve McCurry, who's not mentioned by anyone else. And I'm wondering, like, where's this coming from? How is this basically created? And then we can also move out and not look only at individuals, but at the data set as a whole. So for all the humans in the list, I also requested their gender. And basically, this is what came up. So it's a very male-dominated list where men are basically named 3 times more often than females. And everything in between and beyond those binary scales are more or less neglected at all. And the like me as a professor at a university, I'm asking myself, like, if more and more bachelor theses, master theses, PhD theses are written with this system, is this really the representation we want? And I think this is something that trying to act upon this and think about it. But at the moment, we have a very, very skewed image of this. And then there are all these kinds of clusters that you can see in the map and that are telling pretty interesting stories. So this is the whole map with their 31 fields, subfields and items, but we can also look at specific subfields. So what you see here is arts, and arts spans this like vast region within it. From virtual reality at the bottom left to this very strong cluster at the top right that is fashion within it, which is Coco Chanel, Karl Lagerfeld, the Fashion Week on the top right. And then something like astronomy, where you have that occupies this region on the very center left outskirts of the maps, and it has this like very small names. But then the more it moves into the middle, the more central nodes become like Albert Einstein, Isaac Newton, Elon Musk is in there, Jeff Bezos. So there are this like big names in astronomy that are very central to the map, but the rest of astronomy is very much to the outskirts. Then you have something like education, which is located at the bottom, the center bottom of the map. But then you have this one outlier very up there in the map, and that is music. So somehow music draws together the notion of education and arts within the map. And then what was very unexpected and surprising to me is that geography holds such a central position within the map. It's really centrally located, and it draws together a lot of items from water, animals, wildlife, renewable energy, globalization, United Nations, culture, language, to religion, which was very fascinating to me, that this is how basically the map came out. And then there's something like science that is very much split into multiple parts. And you have like this very strong astronomy connection to the left of science with people like Galileo Galilei, Carl Sagan, Copernicus, Kepler, among others. And then you have mathematics to the bottom left, Karl Euler, Carl Friedrich Gauss, Euclid. Um, and then you have computer science to the right of the map with like Alan Turing, John von Neumann, Jim Berners-Lee. And at the bottom left, there is like the field of psychology located. So you can see that science is split into multiple areas and spans a very large region of the map. And from these kinds of things, I got interested into looking not only producing one map, but producing another one. And I came up, or I got reminded of this book by Michel Foucault, where he basically puts out this idea that there's like this very strange relationship between knowledge and power. So I decided to basically make another map where I ask this exactly same way, go through the exactly same process, but this time not asking for the categories of knowledge, but for the categories of power. So same question, and I won't go through the entire process, but will show you the final map. This is the intro screen that you get when you visit the online map. It's not yet published. I'm in the process of also publishing with it the paper that I wrote about this, but I hope that it will be out soon. So, and from here, you can basically redo the same thing. You can zoom in there and then click on certain things, filter, search, and get some kind of idea how how the system basically categorizes and thinks about a topic such as power. And then one of the most fascinating things to me was looking or just counting how many times a certain item is mentioned, how many times something comes up. So what you see here is basically the list of the most oftenly repeated items within the map of knowledge. And I would just like to draw your attention to a couple of points. So first of all, the entire list only consists of humans. So there are no things or places or ideas, concepts made it into that first list. And then from the 26 people you see here, 22 of them are male. So it's only, the list only has 4 or 3 female characters in here. But at the same time, all of them are at the very top in between Aristotle. And the list is led by Rachel Carson, who's very famous in the respect of climate change and thinking about how to imagine. She led basically the U.S. environmental movement in the 60s and 70s. And Jane Goodall is very famous for her work on chimpanzees. So it is this very, very interesting list. Where I'm not quite sure where it's coming from and why the system basically put these people front and center. But now, with the second map, we can basically compare that to the first map. And to me, it's fascinating to look at how are these two maps between power on the left and knowledge on the right. How do they distinguish from one another, and how do they overlap? And what you see here now are the people who are basically mentioned in both maps. And you can see that Rachel Carson, Jane Goodall, Aristotle are all also mentioned. Alan Turing is mentioned in both maps. But you can also see basically the differences between them. And fascinating, so between those two versions that I made and the scrapings, that were on about half a year. And somehow in the new map on power, there were much more female characters in there, but also things and items. So the second place is the internet. Then there's the printing press, propaganda, artificial intelligence, which is interestingly has the same number of counts as emotional intelligence and social media. So somehow the system is adapting and is changing, and there are new people who are basically mentioned. So from this, one thing that I find very interesting, and a notion that comes from Kate Crawford, which is that basically AI is this like registry of power. So if we look at it, we see where things are coming from, and we can basically through this map somehow interfere or get some kind of understanding where things come, or how they make sense, or in other words, to say it differently, to understand what this map is, we have to look at the infrastructures that surround what we call large language models. And apart from this computational layer, I'm at the moment interested in three different topics within this. I'm interested in the data and where it comes from, the labor that is put onto this, and the resources that are used to produce these systems. And let's talk first about the data. So the amount of things that go into these models are counted in tokens, and tokens are somehow word fragments. So it's not 4 words, but more like word fragments. And about 3 billion of the tokens that are trained to produce ChatGPT come from Wikipedia. But this is only a very small fraction. ChatGPT is also trained on a couple of book corpora, one that has 12 billion tokens, another one has 55 billion tokens. But the vast majority of the training data from ChatGPT comes from a system that is called the Common Crawl. And with 410 billion tokens, so it's very much the largest part of this. And the Common Crawl is basically a website that is all the time going through all the websites that are out there in the web and scrape all the textual informations that are on these websites. In September, October 2023 alone, Common Crawl archived 3.4 billion web pages. This means if you post anything on the internet, if you have a blog, if you have a website, if you have like a little site, or in your case, your own domain, it is most probably part of the Common Crawl. So this is getting crawled, and then this is used to train ChatGPT. And there are many cases who say this is stolen data. And for that reason, OpenAI, the company of ChatGPT, is in quite a lot of lawsuits at the moment, from Hollywood writers, novelists, music writers, to also outlets like the New York Times. But in addition to that, this data comes with historical baggage. So all the things that might not be okay to say today, but that have been like 50, 20, 100 or 200 years ago that are in this training data, they basically get reproduced within that. And for the second map, for the power map, I asked ChatGPT to give me some kind of ethnicity dimension for the individuals that I'm getting the data back. And this is basically the result of that research. So first of all, the system never complained that this might not be an adequate request, but rather it returned some kind of a racial or a not okay categorization scheme for individuals. Caucasian is a term that should not be used, but because this is only something we have figured out relatively recently, it is still in there. So there's there's another layer on top of this, which is that the internet, as all of us know, is not filled with the purest knowledge of humankind. There's bullying, trolls, stalkers, crimes, spam, pornography, violence, hate speech, radicalism. So there are all these things. And because the Common Crawl is just like scraping all of this is also within these models. So what are these companies doing? They're basically adding another layer on top of it, which is labor. So in the Time magazine in January 23 published a story how OpenAI is basically outsourcing labor in Kenya to people who are earning less than $2 per hour to make ChatGPT less toxic and basically remove those links. So we are basically exporting or having the global south cleaning these large data sets that are extremely problematic. And these people have to look at child abuse, murder, suicide, and read through those texts and basically clean the system up. And it's extremely questionable if we really want this or if this is worth it. And then on a third layer, there's a big problem with resources. These systems are incredibly energy hungry. So you can look at the environmental footprint of this. It's estimated that ChatGPT consumes about half a liter of fresh water for one request. So at each time you ask something, it's basically half a liter gone, which is crazy. 700,000 liters of fresh water are needed to train something like GPT-3, and the bigger these models become, the bigger this footprint becomes. Obviously, it's heavy on carbon footprint, it's heavy on water, it's heavy on electricity. So we have like all these problems that are around this technology and that make up what the systems are basically producing. And I think we should not stop this progress, but we somehow should be aware and cautious what is happening and how we want to engage in this. The artist Hitro Steil has this notion of the mean image, and that is referring to how the systems are always like calculating the averages out of this data sets. And we should really ask ourselves if like this averages is really what we're looking for. And I think that culture and creativity is so much more than like a statistical mean of past data. So, and with that, I've basically shown you a little bit how I like to do this, like interventions and reflections upon these technologies. But at the same time, I'm also aware that this is a very negative ending. So I wanted to give you a little outlook how I'm thinking about this and how I'm currently engaging with this technology. And one notion that I very much like and that I often do with my students is AI opposition. So because these systems basically calculate some kind of mean, some kind of average of the data that is fed on them, we can use it to basically give us the ideas, but then not use them. So I'm working at a film university and I just made this, hey, give me a title for a funny movie. And rather than picking one of these titles, these are basically the things we should exclude from the beginning on and then think about new things. So thinking of it rather like this is everything that has already been made, and rather than use that as something that we can go beyond and that creativity should avoid. And then I very much like this notion of the Centaurus. So since May 1997, when IBM's supercomputer Deep Blue won against chess world champions Garry Kasparov, there's no human in the world who could ever beat a computer at chess. But now, 27 years later, human chess is more popular than ever before. Humans are still playing chess. And not only that, but a new coalition emerged that we call the Centaurus. The Centaurus is a team of a human and a machine. And interestingly, an average player paired with an average computer can beat a very sophisticated AI version of a chess player. So there might be something new on the horizon here in this coalition between humans and machines. And finally, I want to end my talk theological. In 1710, the German mathematician, philosopher, and scientist Gottfried Wilhelm Leibniz published a book with the title Theodicee, meaning the justice of God. Within the book, Leibniz attempts to answer the question how suffering in the world can be reconciled with under the assumption that God is omnipotent, omniscient, and good. The question is how to solve the problem of evil. The problem of evil is this notion in theology where why is there evil in the world if there's a God who can solve everything? And it's a real problem they're thinking about. And the answer that came from Leibniz is that basically God is a computational system that is all the time calculating the best of all possible worlds from the point of, from the perspective where we are today. So God is trying everything, but there's only so much he can calculate at a time, or she. And in my opinion, Silicon Valley is currently trying to sell us a similar but different idea. We're not getting the best of all possible worlds, but we are getting the most average of all possible worlds. And this might not be enough. So there's still a lot of work ahead of us. And with that, I thank you very much for listening. And I'm looking forward to the questions.
Thank you very much, Professor. That was a brilliant speech with a lot of interesting insights. Thanks a lot. And while our colleagues are thinking about questions, we already have one question in the chat. It's about visualization. So I don't know if everybody can see it, so I'll just read it just in case. So the question is, visualization assists sense making and decision processes, judgment. Not all visualizations are helpful or make sense. What is your criterion for successful, useful visualizations? Can some visualizations be so complex that actually render sense making difficult to or even impossible? To what extent can we trust a visualization if we can't corroborate the data? So yeah, I think that's the first part.
Yeah, this is it's a wonderful question. So and there is within the computer science branch of visualization design, in my opinion, there's a very strong narrative that is basically simplifying visualizations as much as possible. There is Edward Tufte, who basically said that who's very famous for this notion of the data ink ratio. And they're doing a lot of, so the idea of the data ink ratio, I should maybe explain it, is that you should have like all of the ink that you're using on the page, all the pixels should be used for the data, showing the data, and not being used to show other things, to have unnecessary baggage within the graphic representation. There are many studies that basically say that the best visualization always is something like a bar chart, so something very simple. But I'm coming from a slightly different idea, and oftentimes the graphics that are doing have are trying to show the complexity of systems. And I'm oftentimes unsure if this notions that we're having, this reductionistic perspective on visualization design, is really the right one. I'm wondering if if we're having a plot and we're showcasing Germany and Japan, and these are two circles, if a circle can really be give justice to to such a complexity as an entire country in its own. And this is, I think, true for most of the visualizations that are out there. So my perspective on this is that I'm trying to make things that might be overwhelming at first, but at the same time also give justice to the complexity that is out there, and showcasing more, making it enriching the visualizations that I'm making for the sake of showing that things are not as simple as they might appear. So we just had the US election, which is a very good example for this. where we had in 2016, we had this needle from the New York Times saying which if it's Hillary Clinton or Donald Trump. And to calculate this one data point, basically, this one number, there is a giant model. There's so much data going into this, and all of that is hidden to the person visiting the website. And I think this is a mistake. It is very much we should embrace the complexity and also make people have systems that are basically translucent within that. Yeah. So fantastic question. And yeah, it's a field I'm working on very much.
Okay. Thank you. Thank you very much. We have another question also in the chat. Dear guests, please feel free to raise your hand and turn on your microphones and cameras. But meanwhile, I'll read the question that appeared in the chat. Thanks for insightful presentation. Could we consider literally knowledge package of data of LLMs as worldviews?
Yeah, it's a good question. Most probably, so I think as I try to allude to, most probably not the data alone. So the data is like only one part, as I alluded to. It is also all the other things. So, I mean, OpenAI is basically creating these models and then adjusting them. So you can't, the system is not allowed to talk about pornography or sex or violence. So they're pruning it. And then they also have these workers who are basically dealing and training the system for very little money. So I think that also goes into it. And then like a big discussion point are the resources also in Silicon Valley. So they're trying to basically now, especially in the US, to get much more electricity available to train because they're so energy hungry, the systems. So there are like a lot of constraints. And I think, but then given those constraints, I think there is some way of talking about a worldview, most probably. Yeah, but it's a bit more complex than only looking at the data that goes into the systems. Thank you.
Okay, thank you. Okay. Yeah, people are still using chat. Not a question, but a prompt to elicit a response from the excellent speaker. An interpretation of a visualization is always an interpretation, a rhetorical act, which is something contestable and related to power structures. So yeah.
Yes, I agree 100%. Yeah.
Yeah. Thank you. Maria has a question. Maria, please.
Yeah, sure. Sorry, my camera isn't working today. Thank you a lot, Professor, for such a brilliant speech. I will shortly introduce myself. My name is Maria. I'm a master's student in Higher School of Economics, Moscow. And actually, I was so much inspired by your research on artificial worldviews. So I used this as an inspiration for my bachelor's diploma, using this concept of power and knowledge. And I tried to apply this method to analyzing Yandex.GPT, Russian AI neural model, like ChatGPT, but in Russia. Yeah,
Wow.
and yeah, and it brought us so many fantastic and kind of complicated, I would say, so results. And therefore, I would like to ask you a few questions. Maybe I will have not a few, but a lot. And I would love to hear your opinion on that. And so the problem we have discussed a lot was the way of phrasing questions, because based on how we formulate the questions to the neural model, it often influence the way it answers us. And therefore, I would like to ask you, have you experimented with different ways of phrasing questions to see how it impacts the responses from ChatGPT, and what patterns or changes, if any, did you observe in the answers based on the question formulations?
Yeah, thank you so much. It's wonderful to hear that you're working with the same kind of methodology. I would love, please send me an email. I would love to see the results of that research.
Thank you, of course.
Yeah. Um, so, and yes, it's definitely true. So I'm not sure how it is in your system, but ChatGPT basically has you give it two kinds of prompts. If you're, I haven't delved into the technological parts of this, but you are having on one side you have the user prompt. So this is where I'm always asked it for the different categories and subcategories, and then the creations of the data sets. But then you also have a system prompt, which is basically guiding the or giving some kind of indication how the system should think about itself. So this makes it even more complex. And then in addition to that, you have another parameter, which is called the temperature, which is a value between 0 and 1. And so the lower the temperature, the more conservative the system answers, and the higher the temperature, the more creative, the more widespread the answers are from the network. And I actually went in and created a couple of ways, both in the system prompt as well as the user prompt. And then I basically settled on one way to ask the questions, but then I always asked it in multiple temperatures. And this is something that is basically in the data set, but I haven't made the analysis on what the difference is or how really that changed the answers. But yeah, there is, I think it's definitely true. And I mean, just as the prompt before your question, I think I'm not trying to make this project really something that excludes me. But I think it's fine if that is also if I'm some kind of part of the experiment, if I'm part within the setting, as long as I make it explicit and as long as I'm stating how I approached it in a way, I think that makes it, because there's so many ways of asking these questions and so many ways it will change the result, that I think there's no way of getting to some point where we can say, oh, this is now the perfect question. But you should always make your standpoint clear in the way you're asking these things.
I see. Thank you so much. And I
Yeah.
have another additional question.
Please excuse me. I'm sorry, Maria. Please ask one more question, and we will have to switch to
Only
other.
one. Only one. Okay.
Sorry.
Sure. Yeah. So when in our research we tried to ask Yandex GPT a few questions about power, we have faced with a lot of limitations in answers. For instance, sometimes Yandex GPT even declined to answer us or reply us at all to some questions. And I would like to ask you, were there any particular difficulties or limitations in generating responses or interacting with ChatGPT? And if yes, what strategies did you find most effective for managing these interactions? Thank you.
Yeah. So I especially in the first version, the one on knowledge, I had quite a lot of problems. And oftentimes I didn't got responses. So basically the API was not really stable. That was a big problem. It became much better in the second version on Power. And now OpenAI has a new feature, which is this like bulk. So you can send it like thousands of requests, and it's basically giving you back a data set in 24 hours. of all the requests that you sent. And this really makes it simpler and better in like getting results from the system. So yeah, it changed just dramatically. But in the beginning, the API was really a nightmare to deal with. Yeah, so I can hear your pain, but especially look into this bug feature. It's really got very, very good, especially for this kind of research tasks.
I see. Thank you so much.
Yeah, pleasure.
Thank you very much. And I will, if you have a couple of minutes more, Professor. So we have two more questions in the chat. Thank you very much for the presentation. Could you please tell more about AI opposition? How do you embed this practice into your overall understanding of AI interaction? Should these practices be normalized?
Yeah, I'm not quite sure. I think it's more like I'm a professor at an art school. So, and there we oftentimes, I think nowadays my students often think about a system like ChatGPT as something they go to and they get an answer, and then they move they take one of the results. They're saying like, hey, I have to come up with a name for my project and please give me 5 results. And I'm just trying to get them out of this idea that the system knows more than they do, and that that the system has better ideas of how to work with this. And so the AI opposition is an idea of saying like, hey, whatever you get from that system, that are the things many people have done before. That is the names that are used all the time. So get out of this frame. Culture is always about producing new things and going new ways and testing out things that are not in the training data of the systems. So that is basically, I'm not sure if this idea of AI opposition is something you can apply to every field, but I think especially for my students at the moment, it's kind of a fruitful frame of reference to have a different approach towards the systems. Yeah.
Okay, thank you very much. Okay, another question is, thank you for your presentation. Why do you use the term worldview and not ontology? And
Yeah,
I'm sorry. Yeah, this is a bit technical. We have one more question in the chat, so I'm not so sure how many minutes more we can keep you. So I think that should probably be the last, or
yeah, there's one question below that. So I mean, like I can't really give an answer. I think like to the first question from Sylvia, I mean, like calling it AI ontology would have most probably even made more sense. I think the term worldview is most probably one that is more widely used within all kinds of circumstances, or that is not as academic. So as a project is something that is also attracting people that, or I'm hoping that it attracts people from all kinds of domains. It might just be a term that is more open, but I think talking about ontologies here would also make a lot of sense.
okay, thank you very much. And our, I think, last question is from Feride. What are the legal side of these generative AI violations that Professor Kim mentioned in the computational averages, as what we call AI is a set of nested noxious operations?
Yeah. So I mean, I have a research position within Harvard. My research position is within the within a department that looks at the legal sides of the systems. But I myself, it's a Berkman Klein Center for Internet and Society, and they're dealing with a lot of like lawsuits on the internet and how to think about these terms. But I don't think that my domain knowledge is really capable of saying what these violations are and how to deal with them. There are different perspectives on this, and all I can say is that it will be pretty interesting, or that a lot will happen. but how this legal fights will turn out and what it really means is very much unclear to all of us. Yeah.
Okay, thank you very much. And for today, you have raised your hand.
Yes, I just want to thank you for this brilliant presentation, Kim. And we are going to write you an email that I sent you. Thank you very much. And the only thing the basic question here, I'm sorry, this is not a question, just my concern about all of these things. So this data violence is what we are talking about, is a nested operation. So we all has been stored as all our digital, tracks are stored in somewhere as a big data, and we don't know what is going on there. It's still a black box, as you mentioned. And then the legal side is still very, very confusing.
Yeah.
And it is a niche academic area for us maybe to focus on this part. Thank you.
Yeah, it's a pleasure.
Yeah, okay. Thank you very much, Professor.
Wonderful.
And
thank you for
thank
having
you.
me. Yeah.
Thanks.
Have a good evening, everyone, or good day, wherever you are.
Yeah, you too.
Nice
You
meeting
too.
you.
Many thanks.
Ciao.